Hi everyone, and welcome to NDC Oslo. I hope you had a great session today, that you have seen a lot of good talks, and some of you who are presenters ready for the NDC boat dinner, which is cruise dinner, which is going to be really, really good. So I'm the last talk, so hope that you'll have a really good night tonight. All right, so what I'm going to talk about today is the common mistakes in EF Core. And interestingly enough, started this talk kind of a few years ago because I was a little bit annoyed of fixing the same things over and over. But later I really realized the reason why I was so annoyed is because most of these issues, they don't have much problems. They're just, a little bit of annoyance, a little bit of performance issues, or maybe a couple of bugs. But some of these issues caused people to work over weekends, caused projects to fail on day one. How many of you have heard about government websites going live and then going offline because it didn't didn't handle the load? So some of the things that might have happened that day are in here. So yeah, you might want to remember some of them. And that's basically the motivation for it, is so that you don't get those moments where it's like, it worked in production, it worked in staging, it worked, sorry, not production, actually did work in the production. Just once people come in and start to use your system and start adding data to your database, things starts to fall over because it wasn't developed with high volume data. All right, that out of the way. I am Jernej Kavka, but you can just call me JK. I'm actually originally from Slovenia, quite close from here, but I live now in Australia. So, in spite of being close by natively, a very long trip. You have lots of socials. I'm on Twitter, GitHub, my blog, then also LinkedIn. I organize quite a few events in Australia. And if you're interested about AI, I also am one of the hosts on the Global AI, the podcast. We actually just covered the OpenAI team, and it got dropped like 2-3 hours ago. So you can learn more about OpenAI. And I am a .NET Core developer, mostly specialized in EF Core. And I'm also an AI MVP that works a lot with ChatGPT, ML.NET, and things like that. And this is something my company makes me do, is you can scan the QR code to get this app, and at the end, when you scan another QR code, you can win some rewards, which I hear are pretty good. I can give you QR code at the end if you want. All right, so intro. So I kind of explained a little bit the motivation behind of why I'm doing this talk. But at the beginning, I'm going to show you things that will allow you to replicate what I'm doing. So I'm going to show you some links, I'm going to show you what my machine is and all of that stuff. So you can just take the GitHub code and try it for yourself. So you can see how different changes have impacts. Then I'm going to move to seven deadly sins. Those are the 7 most deadliest things I have seen in EF Core that happened too frequently. And at the end, I'll do a couple of mini best practices. All right, so how many of you know more than 4 or 5 different databases? All right, just a few hands. But the longer you work in the industry, you're starting to see that there's a lot of databases popping up: SQL Server, Cosmos DB, PostgreSQL, and MySQL, right? And we have lots of bunch of ORMs as a result to handle all of these databases. So for instance, you want to go SQL Server, and then it's like, no, I want to go to Postgres. you can either choose to write SDK-specific code for each of the databases, and then you have lots of issues migrating. Now, in practice, as much as a lot of people say that you move between databases, it doesn't happen frequently, but when it does, having ORMs is really good because they handle the abstraction between all of these databases, and now databases are just popping up all the time. So one day your boss comes in and says, hey, Cosmos DB is really cool, let's go on this. And you're just like, okay. So this is why EF Core is great, because it kind of gives you the best balance between features, flexibility, and performance. And it's really good relational database, and it has built-in migrations, the database scaffolding, and other tools. Now, if anyone is doing migration from database first on .NET Framework, might know how useful it is to have database scaffolding, because you can just take the database and then convert it in code first, and then just continue on with the built-in migrations. It's awesome. And the thing here is EF Core basically allows you to also switch databases, which is really cool. It still requires work to achieve that, but your business logic can remain the same. And the part of this presentation is basically how can we resolve some of the issues with EF Core. Now, all of the stuff that I have told you now is the reasons why you want to go to EF Core, but the next parts are going to be the issues that people find and say, why did we go to EF Core? There's so many issues and stuff like that. And then you just look at the code and you're like, you know what? The issue is not really EF Core, it's how you structured your query. So I want to show that. And when I'm going to show you all of that, I want to show you that you can actually also simplify your code by doing best practices. And I'm going to give you benchmarks for the code that's written and some with the tests. And I'm going to show you a few horror stories without mentioning any names, or give any scenarios that could link to them. All right, so this one really quick, the benchmark tools. So the first couple of tests are going to be via benchmark.net. This is to show you the impact on memory consumption and time for a single execution. The first two make sense to do them. For the rest of them, there's not really that much of a difference, so I just skip them. And then the Bombardier is the tool that I used for all of them. And what this one does, it allows me to use a simple command line to hit, for instance, an API, 20 threads consistently for, say, 60 seconds. And then I can see how many requests have I handled. Now, this is not technically load test. It's just, gently loading up requests. It doesn't try to overwhelm the service. But it gives you an idea how your website will work, how that endpoint will work when you start getting more loads. Because in one example, you'll see, it's only 3.5 times slower. And then in another test, you'll say, oh, wait, this is a lot more than just 3.5 times slower. I'll get to that one. And just in case you want to verify my timings, .NET 7 with EF Core 7 and Ryzen 9 with 32 gigs of RAM. I'm just putting this there in case somebody wants to play this with this around at home. The test data is 7 million sales. It's a very simple database. We have 500 products, 20 employees, and 20,000 customers. I intentionally picked a very simple database because this kind of database shouldn't give you much performance issue or much issue at all, but you can get to big troubles if you write really terrible SQL statements, link statements. All right, now to the fun part. 7 deadly sins. So the first one, some of you might know what happened here if you have iQueryable and you cast it to IEnumerable. Then we have as-not tracking, explicit joins, getting all the columns from the database. And we have no paginations, non-cancelable queries, and inefficient updates or deletes. And when you hear all of these 7, how many of you have asked yourself in your mind, how bad can it be? One advice, never ask that question. There's no good answer to it. So let's go with iQueryable to IEnumerable. So we have this one. We have toList.count, right? And then we have this one. We are taking these sales, we're putting into IEnumerable variable, and then we count it. And then we have a method that returns a IEnumerable list. And then basically we count this. Does anyone think these things are different? Well, they're all the same. And they're all the same because if you do toList, you get the entire database. If you cast it into IEnumerable, that's almost like you're doing toList. You're getting all of the data, all of the sales from the database. And what is the most common issue that I see is that developers want to be good, they want to be abstract, and then they say, you know what, I'm not going to do the type that's, say, the DB set, that the sales return, or iQueryable. I'll do IEnumerable because, you know, it's the highest one that you can do. It's the highest one in terms of type compatibility, right? They're trying to be a good developer. But in this particular case, this is really bad. In all of the other cases, IEnumerable is actually good. So what happens here is we're making an HTTP request. Here we have down below the IEnumerable salesdb context.sales. And what happens is when we are trying to evaluate the query, the EF core query, it will only evaluate to the point where we hit the casting to IEnumerable, or we do toList. So what we end up with is a select star from sales. And that means that it literally downloads the entire database. And then, as you've seen in the code, we just count them. So it just looks at the number, how big the list is, and then dumps all of the results into garbage collector. We never used any of the data that we received from SQL Server. So here, the simple solution is to use iQueryable when you return in methods. Now this is the simple part. Let's go to the fun part of, so here, if you use iQueryable, you basically, the entire statements gets translated, and then you have select count star. But you know, it's not interesting to just see, okay, just avoid IEnumerable. I was just like, you know, I really want to burn that in everyone's mind. So what I'm going to do is I'm going to ask myself, how bad can it be if you don't do that? And yeah. Remember this slide. iQueryable is in EF core is not the same as IEnumerable. So why is this bad and how bad it can be? How about 2 gigabytes more memory consumption? Does that sound bad enough? Then, okay, it's 64 times faster. Actually, 64. So this one ratio, this one is average, whereas this one is mean. So basically, it means that most of the queries were somewhat fast, but at some point it just tipped over and everything was slow. But that's not the fun part. What if we load test this? Here we have 3.5 times faster, and here 64 times faster. These are just numbers, right? What if we have lots of users using with this feature? Well, what happens is that the average response is 33 seconds. Just to get count of sales. Yeah, imagine that. It takes 128 milliseconds if you just do the right query. So now this is 260 times faster. Big numbers. So see here how much impact an enumerable in the wrong place can make. So this is, if you remember anything, remember this. You'll make my life easier. All right, so the next one is AskNo tracking. And this one, what does is it allows a query, which is by default trackable. That means that if you change it and you do save changes, it basically will know, okay, this entity has changed this property, so in the database we need to change this row for this column. And if you need that, that's awesome, and you should use it. But when you don't, what you can do is use .AskNo tracking. Now, I'm putting here warnings because some people warn me, don't tell them because then they will use it and then no changes will happen in the database. So here I am saying for the third time, no changes will be made in the database if you use AskNo tracking. All right, so what happens behind the scenes? So when we generate queries, we send the query on EF Core, we send the query to SQL Server, we get back the data, we pass the data and map. This is all done behind the scenes. But there's an extra step to it. We are doing EF Core tracking behind the scenes. Basically, it hides some data that you cannot see directly in your code to know how your entities are being changed. And then you get back results in the code where you can use it. So here, any changes that you do against the entities that you get back this way will be captured by save changes, by DB context save changes. Now, if you do AskNo tracking, this step is skipped. Now, why this is important is not just because it won't be tracked. The other thing is it can use significantly less memory. In my test, it happens that it used 4 times less memory. What I realized is there's a very wide range of performance gains or memory consumption gains depending on the query. So your mouse can you might get different results. Also, it's faster. Now, the thing here to keep in mind is, does anyone know Nick Chapsas? All right, you might have seen his video about EF Core performance, and he says, well, don't use AskNo tracking because it doesn't give you any benefits. What I realized is that there might actually be differences between the database providers. So in his test, he actually didn't get any major differences when he used AskNo tracking. But on SQL Server, I got pretty major differences. So keep that in mind as well. So if you use this for performance reasons, make performance measurements before you're like, yeah, just use it everywhere. So timings-wise, we have 4 times higher speed when we load, test under load. So basically, the reason why I'm focusing so much on the speed here is I'm dealing with applications that needs to process a lot of data. They need to also process a lot of requests. And the longer you take to process things for unnecessary reasons, the fewer requests you can process, the more likelihood is that your server starts to get overloaded and toppled. And as-no tracking is like a very easy thing to add, especially if you know that the data is not going to change. It gives you a little bit more buffer between your server working fine and your server just exploding because it's just getting too many requests to process. And also very important, this mostly impacts the .NET side. So if your .NET side is running really hot, you can alleviate a little bit on the .NET side. It doesn't have any impact on the SQL Server side. Another really annoying thing for me is .include. The reason for it is a lot of people like to do .include, and then they forget to remove them when no longer needed. And they're thinking, yeah, if it's no longer needed, it's not going to query by that data, right? It's just not going to include join. Well, it turns out even if you do .select to map your data, it will still do the .include, even if you use it nowhere. So it will do joins, and if you know SQL Server or SQL in general, joins are one of the more expensive operations you can do. So the way to go around that is actually using implicit joins. So what you can do is, instead of doing like here where I have a .include and I'm including the salesperson, you can instead just make a select statement where we directly use those tables as properties. What happens here is it will implicitly include whatever we're adding into select. Therefore, if we remove these two lines, there won't be any join statement. And this basically alleviates you from checking every time if somebody forgot to remove an include statement. And I'm not sure how many codes you have seen. We have one master method where it has literally 100 lines of includes, and I'm just like, why? I understand why would you want to do that if you don't have any performance, and if that doesn't literally cause your database just panicking, saying, wait, I need to connect everything with everything. But still, why? And to show you the impact here, it's 2.5 times faster. And in the end of the day, you're getting exactly the same result. And if you look back in the code, you're actually more clearer what you want. Now, you might hide this code in a mapping library, so it might not be as abundantly clear. You might need to jump to the mapping code. But still, it's very clear. This is the data I want. Just get me that. And you're getting free performance out of that. And talking about mapping and fetching data, pagination is one of really major problems that I have seen, especially on projects where you have developers that are not used to deal with really large data. Like if you're dealing with systems that deals with licensing, you could potentially have thousands of licenses per product. And all of a sudden, when you try to load those licenses up, it quickly comes from, on production for 2 weeks, it worked everything fine. Then people start purchasing one product, and when you try to click that product, the whole system freezes up. That actually happened. It's like, I click that product, everything looks fine. Click that product, It's a little bit slow, but everything fine. I click that product, and all of a sudden, nobody can access the website anymore. It's like, it feels like almost that that product is cursed. But what ended up happening is almost the same mistake as at the beginning, where we had essentially dot count on the entire table, download the entire table and dot count. A little bit less bad, but still similar. And what the most common code that I have seen on how they're trying to do pagination is this. So what they do is they're doing correctly at the beginning. You know, you do the where clause, you're trying to add whatever you need in the query, but then they're getting all of the results. And I was like, why are they trying to get all of the results before they do pagination, all of that stuff? It turns out they don't know how to get the count from the database for the filter. So they first get all of the data, then they get the count, and then in memory, they filter it down. And what usually happens is like, well, it's good enough. You know, if we try to fix this, there's no performance issue as far as we can tell. But then the data starting to increase, and all of a sudden, there are issues. Oh yeah, here's the in-memory pagination. So what you should really do is essentially use iQueryable so you can reuse the query more than once. Do whatever you need to do. And then on that query, on that iQueryable, you do a dot count. And later, on that same query, you apply skip and take. So that will do depagination. And then you get all of the data. Now you'll be saying, hey JK, you're now doing 2 requests. Isn't that slower than 1? Well, you would think so. But the thing is, this dot count in SQL Server is surprisingly fast. A lot faster usually than getting more than 1 page of data. So that's the performance hit I'm more than happy to take, because that's like a few milliseconds. Because if this thing goes wrong, we're talking about seconds or even minutes of performance penalties. So yeah, this is a lot faster. I'll wait just a little bit and seeing some people are taking a picture. All right, so what's the damage here? Well, we have 1.3 seconds. That doesn't tell us a lot. 75 milliseconds if you do pagination, which is 18 times faster. And just keep in mind, in all of these cases, we're returning exactly the same thing to the client. There's no changes. We only change how we execute the query. And we're gaining insane amount of performance gain. Also, one thing that I forgot to mention at the beginning and here is, from the first case onwards, I stopped querying 7 million databases, because when I did the bad cases on 7 million cases, my machine was unresponsive for 10 minutes. And then I was just like, cool, I have really awesome numbers to show and comparison. But then I also realized that I won't be able to reuse my machine for 10 minutes. So all of the data, all of the tests that I'm showing you have reduced data set. I think it's 700,000 or a million. Just to give you a perspective of how bad things can get, I literally had to reduce the number of set, otherwise my computer was unusable. But in all of the good cases, there was at no time more than 5 seconds that my computer was unresponsive. So that's how major of a difference can make from, doing a very horrible thing and very good thing in EF Core. All right, talking about horrible things and things not stopping. Non-cancelable queries. It's almost like I knew this slide is coming. So this is a very interesting topic for anyone who don't know what a cancellation token is. How many of you, oh, actually, let me reverse the question. How many of you know cancellation token? Okay, we have a pretty good number of people, about 3/4. So how many of you are using cancellation tokens on EF core queries? Okay, maybe a quarter of the room. Okay, so this one might come as a surprise for some. So let's say you don't use cancellation token on queries. What's the problem? Well, let's start simple. Let's start with HTTP request, doing some things, then you make an EF core query, and you know how you have some of those queries that are very complicated, but you can't do anything about it. It's just, you know, if it's going to take 30 seconds, it's going to take 30 seconds. You just not much you can do about it. And, you know, it might be a use case where that's fine. The user can wait. But what happens if the user canceled that request, that HTTP request? Well, if you don't have a cancellation token, that thing still runs for 30 seconds. Now, what happens if somebody starts to spam F5? Yeah, you might guess that nothing good. So this is why you want to use cancellation token, and I'll get to juicy numbers shortly. Basically, what you want to do is, when you're using Web API, and if anyone is trapped with .NET Framework, you can do that as well. I know that, unfortunately. So when you're doing cancellation token, you can apply to toList async, and that will hook up to the cancellation token that is for that HTTP request. So when that HTTP request gets canceled, it will also get canceled on the EF core. But there is a little bit more magic to it, because if we look back to the same example, we have the HTTP request. EF core sends the SQL to SQL server, and SQL server starts to process the request. When we do cancellation request, it's not just that .NET says, okay, I don't need to process this thing. What also happens is that request gets pushed to SQL Server, and SQL Server is like, oh, you don't need that anymore. Fine, I'll stop. So what happens is they both stop. So if somebody is spamming F5, now there's going to be a bit of overhead, but generally speaking, things stop. And you won't overload the system because of that. So what happens is, here I intentionally picked a query that will basically took longer than the timeout that I put. So I put a timeout in 1 second, and I basically did a query that literally downloaded 7 million. Actually, I think I did reduce to 2 million because I actually wanted to use my computer. Anyways, the point is, I used a query that takes about 2 seconds. And what happened is this. So at the end, the latency ended up being 10 seconds per request on average, which is pretty bad. And that's without cancellation tokens. When I used cancellation tokens, it only halved to 5 seconds. So it wasn't like it was, you know, just 2 seconds or just 1 second. The system got overloaded. And with overloading it means that the code actually starts to slow down in terms of execution, and that also meant that cancellation token didn't quite came as fast as they should go to the .NET part as well as SQL Server. Now here, what we're talking about is trying intentionally overloading the system to test how well this works. But despite all of that, it got 2 times faster. And the thing about this is the cancellation one, with the cancellation token, it took about 40 seconds to get back responsive. And this is by me trying to overload the machine. When I didn't have cancellation token, I couldn't move the mouse for 10 minutes. it was keep churning and churning and churning, and I had to wait for every single thing to be processed until the machine is even ready for me to move the mouse. So that's how bad it got. And yes, this is why you want to have cancellation tokens. And this is the easiest way, if you don't implement cancellation tokens, how you can DDoS a machine. In fact, you wouldn't even need to DDoS them. At this stage, it's just denial of service. Just, you just hammer F5 really quickly. That would be the denial of service for this kind of endpoint. Just hitting F5. All right. Now, the last sin is the inefficient update / delete. Now, before EF Core 7, this one was a bit harder to fix. But with EF Core 7, this one is now a lot easier to fix. So the problem with updating in EF Core, some of you may know, is you need to get data as tracking, and then you need to do the changes. Basically, it means that you always have to make a select statement, a select SQL statement, and then update the thing or delete them, right? So it's quite inefficient, especially if you need to update 7 million records. That can take a long time. Remember that toList.count? About that amount of time. So instead, now here I just did for fun, changing first name to last name, just for fun. Here we have a simple process of changing first name and last name, and what we have to do is get all of the people. Then we go to for each loop, and then what we do is swap those properties around. You can do whatever else you want to do. One common thing that's happening when we're talking about really large data is basically just flipping a 0 to a 1, feature toggling, for instance. For all of the users, you want to enable a feature, or for instance, you're processing data, and then you say, I processed all of the data up to that point. And historically, EF Core didn't have a good way of dealing with that problem. You end up using raw SQL instead if you had to deal with big data, because any other way, it just wasn't acceptable. But also, you have here SQL statement as well. For each of the employees we change, there's a separate SQL statement. So if you have 7 million records, that means you'll have 7 million update statements. And that thing can grow really, really big. So instead, what you can do is you can actually just execute updates directly on SQL Server. So what I'm doing here is I'm just saying for the employees table, execute this update, and let me see, and set the property first default, so first name to be last name. Now here, instead of this last name, you can just use a concrete number or concrete string or whatever you want to set this property by. But I'm showing this example as setting an actual column, because that's the common thing that happens in those bulk updates, is you want to update the existing column to be updated. Say you add an additional thing, or you want to add a number, or swap, say, if it's true, you want to put it at false, or if it's false, you're trying to put it into true. And for those kind of logics in EF Core, you needed to get the data from the database. You couldn't just do this simply. And now you have all of the tools to do that. Whether it's a fixed data you get, or if you need to reuse the data that the column supplies you. And also the SQL update is like really thin. Like you have only one statement, which is awesome. So what happens here is, of course, we're getting better performance, which is great. But one thing that is very important here is if you want to use S-node tracking, for instance, you don't want to have trackable entities. You want to be in control when and how the data is updated in the database. This gives you now the tools to do this. So basically what you can do is you can choose that all of the queries you do are non-trackable. That all of the queries you do don't impact safe changes because you want to be in control. And then if you have a very complicated case where you need to, very complicated relational structure, then you choose to have it tracking. Because one of the things that I'm looking into is, can we fully control of what goes from the SQL Server database and what goes into SQL Server database? And this is, for the first time, this actually gives us that control. Now, if you're just thinking about, okay, how do I use this? I haven't been doing a lot of design patterns and stuff like that. The important thing here to note is just, you can just say, update me this record and update this property to that property without worrying about anything. All right, mini best practices. So we've done 7 deadly sins. Those are one of the worst things that I've seen in production. Now there's some honorable mentions first. So first off, have anyone seen a developer trying to download the entire database just to see if there's any data? I've seen this more times than I'm willing to admit. Just use .any, please. I don't want to see this anymore. You have literally here, I actually looked at this code for 1 hour and I was just like, I was trying to get into that mindset. And I was just like, they probably just don't know what they did here. It's all good. Let's move on. Then what we have here is, this one is something that I'm just like, okay, I totally get where the issues here. So what happens here is we're trying to apply a conditional filter. And what with a lot of developers happens is either they're trying to do overcomplicated where clause because they don't know they can just store the query into a variable and then just do just multiple where clauses and modify the query over time. So they're trying to make that one big bang query and get all of the data and everything that they couldn't fit in. They're trying to just process it later in memory. So instead of doing that, you can just store your query into an IQ variable and process as you go. So for instance, over here, we have sale ID. If it's not null, we add an additional where clause. If it's not, that's fine. We skip it, and then at the end, we do toList. So this is one thing that a lot of people didn't know is you can do that. And a really nice side effect of this is that if sale ID is null, basically the SQL Server is non-divisor. It's not that weird thing where you do .where and then is if sale ID is not null, then filter by ID, otherwise just ignore this. And then if you have multiple optional statements like this, the whole query becomes so unreadable because then you need to think about, okay, why is this? Okay, this is optional. What about this one? This line, okay, this one doesn't look, it's optional. No, it is optional here at the very end. It just becomes really hard to read this. And this is very easy to read. I mean, it does expand a little bit in verticality, but this is very simple code to read. So please don't overcomplicate your clauses. You can just, string them slowly. Now, the next one. How many of you know about DB context pool? Very few hands. Maybe 7? Okay. So, DB context pool. Good thing that I added. So, what DB context pool allows you to do is, how many of you actually know about HDB context pool? Also very few hands. Okay, we need to talk about that. Okay, so let me just explain the XYZ pool in .NET. If it comes from the Microsoft team, that means that whatever that thing is, it's going to be reused if used correctly. What that means in this particular case is when you're trying to get DB context pool, and you add DB context pool, it will try to recycle an existing one. And the way it's going to recycle is it will keep the connection to the SQL Server. So it's not going to be constantly closing and opening the database connection, which if some of the SQL Server expert might know, that connection can linger for a little bit. It can take a bit time to close down. If you overwhelm the SQL Server, all of a sudden you can come to situations, especially if you're not the only application using that SQL Server, that all of a sudden there's no connections to that SQL Server. All of a sudden SQL Server says, hey, I have already too many connections open. And then you look at how many connections are used, you realize actually not many. And that's because they're still closing down. So that improves that thing. And as a side effect, you also have better performance and memory usage because it doesn't have to constantly initialize and destroy DB context pool. But the important reason why I'm adding this is because of resiliency. So if somebody is spamming F5, just this adding pool at the end of DB context in the dependency injection will improve your chance of your application being responsive. It will allow your application to more gracefully handle that load. Just adding these 4 letters. There's a little catch here, although. If you're using dependency injections on the DB context, while being DB context pool, you will have to rethink a little bit how you add that dependency because the DB context pool is recycled. One easy way to do this is to just use an interface in your DI and then just manually inject your dependencies when you instantiate the DB context. That's the easiest way to do it. But just keep in mind, your DB context is no longer, your DB context has to be stateless because it's going to be reused. Another really cool thing, tag width. So what tag width does, and you should append it to as many queries as you can, is it adds a comment to the SQL commands that gets generated. And the reason why this is really cool is if you have a query that is unusually bad, and all you see is that huge jumble of SQL, and you're like, okay, we use this table in that thing, and that column is like, okay, that could be any of these queries over here. We don't know to which one this SQL statement reflects to. But if you use tag width, you can just look at the SQL statement, and it says, yeah, on the top we have the comment. You can just copy that, Control-Shift-F, and find exactly where that link statement is. Now, before EF Core 3.1, you had problems where queries were splitted. So you wouldn't, sometimes multiple queries actually originated from the same link statement. And in fact, you can still do that, but it's explicit. You can do a split query. This tag width is included for both of the SQL generated code. So when you try to copy it and you see, okay, I have two queries with the same tag, but in the code just only one, you now know that that link statement has been split into two queries. And that saves a lot of debugging, trust me. And the last bonus fact, ChatGPT. So if you want to use ChatGPT to basically help you generate your queries or try to explain your queries and things like that, you can just say you are an EF core expert and write whatever thing you want. You can do DB context. You can just paste the code. If it's too long, just remove some lines. You can just paste the entities there. If it's too many, just remove the ones that are not used. And even return types if you want to return something specific. Now, you may notice that I also set N clean code developer, because what I notice is if you don't do that, some of the code that you get back is pretty terrible. It works, but it's terrible. So that's why this is the secret sauce, clean code developer. Now, I have a lot better query, so if anyone is interested, I can share that one for you, but it's a lot bigger. And I also have one where you describe code as mantras, and somehow is better than doing strict rules. But yeah, here's a result of one of the queries. So we have the you are an EF core expert and clean code developer, get all employee details for each, get statistics on how many products they sold, how much they earned, and lists of sales they did, all paginated. Now, with all of the stuff that you have seen today, you probably will be able to do a pretty good query on your first, maybe second try. But ChatGPT got it pretty good on its first try, and it just took a few seconds to do it. So yeah, this is actually pretty good query. If I would send this in a pull request, I'll probably just say, yeah, looks good. Maybe add a tag width. There is no S tracking here, so maybe add that, considering we're just returning all of the data and probably not changing. You probably wouldn't do updates on a paginated query. So this is pretty good. Now that I remembered. How many of you know that when you do select statement, that query is no longer as no tracking? We have one hand. Amazing. So yes, technically speaking. Sorry?
May I also add something to that?
Yeah, you can ask a question.
Yes. So one thing I think that was missing from your good points about all this is that you can also end up selecting more data than you want if your top level is
Yes. So one of the good points is that if one of the good points is that we can get exactly as much data as we need. Now, the reason why I personally still use S-node tracking, even though the technically select does that for me, is if, for instance, here we have product name, and we add an additional line where we say product equal s.product. So we're taking the whole property of product. That property is technically tracked. So you have now introduced a property that's, like, a lot of developers didn't know that actually is tracked, that is not tracked. And if you accidentally change that because you think, yeah, it's just a copy from the database, it's as not tracking because of the select, and then you do save changes, you might have inadvertently changed a data just because you thought that was not tracked. And if you add at the beginning as not tracking, I would need to double check that, but I think everything you access from it, everything you do in the select statement is not tracked. This is why I do that, despite select statement already doing that. Quick question then, and then we'll continue.
Yes. What I actually was talking about was that if you have something in the select that cannot be translated to database query, then it will actually transfer all of the data to the client before the
Oh, okay. Sorry about that. Yeah. So what you were saying is, if there's anything in the select statement that cannot be recognized, in EF Core 2.2 backwards, and I think still in 3.1, it did get you all of the data. As far as I checked the last time, EF Core 7 either fails the query because it cannot be evaluated on the SQL server, or it is successful provided that it can only fetch that specific data. But I think there is one catch to this, that there is one use case where it actually downloads the entire one row, but I don't think it tries to download the entire database. But this is very specific use case, but thanks for that. Yes, ASNO tracking can be sometimes very complicated. And what you put in select statements, especially if you're trying to use something that is not supported on SQL Server, can give you some unexpected results. But from EF Core 5, they tried to minimize those impacts. So instead of having very unexpected results, your performance going down the toilet, it basically just tells you, hey, I cannot execute that on SQL Server. All right. I promise these are the last 2 slides with content, so then we can go for a nice dinner. Before we end, I want to just touch really quickly on how many people know what premature optimization is. We have a few hands. Okay. So one important thing to know about this is essentially, if you worry about some of these things being premature optimization with spending too much time or fixing up these kind of things, generally speaking, if you're following good practices for the given scenarios, that's not premature optimization. You should likely do that. And when you have a method, say an endpoint, for instance, that is expected to have high load, and you don't have time to do performance improvements, you should talk to your product owner and say, hey, we either add this to acceptance criteria or we add a new PBI. This is a high load endpoint. It has to be dealt with. It has to be fast. And lastly, from that section is, when you know that something already causes performance issues, either it could be memory, it could be time, or it could be anything else, try to make a technical debt out of it. Create a PBI or issue or task in your systems, put them into backlog, make sure that you address them before you make a major deployment, and write that in the code. Make a comment linking back to that issue. And this is very important because this is how you're getting those production issues where everyone is up awake on Saturday night trying to figure out what's wrong. And lastly, what you should not do, we'll fix it later with no actions. Don't just say fix it later. As I said before, create a technical debt, put it on backlog, and mark the code with a comment. We'll fix this later. Here's the issue. Link it to that issue. The reason for it is, if things go bad on the day that you release, and everyone is like, we have no idea what's going on, this is the first place you should look. if it's performance issue, if your server is just not responding, and see what you have missed, because there's a good chance there's something you have forgotten about it, and now you know where it is. And another thing, a lot of developers tell me, if I fix this, it's premature optimization. And I look at the code and it's like, mate, this is bad code. Don't use premature optimization as a bad excuse for bad code. In worst case scenario, you create a technical debt, but you probably shouldn't want to leave bad code in your code. So yeah, please don't use that as an excuse. All right, so here are the resources. The first link is where you can try out all of the examples I did. You can do the benchmarks yourself. The second one is Microsoft Resources for EF Core. Now, there is a section for performance. When I started this talk, most of the stuff that I was talking about today were not in it. Today, most of the stuff is in it, and I'm super proud of Microsoft to add that. The problem is nobody read those. So if you want to learn more, go to that page. It's awesome. Also, as SSW, we have SSW rules, so you can check our page about rules for Entity Framework and link. We'll need to do some updates on it. And also, Nick Chapsas has pretty good videos on EF Core and lots of different things. Actually, got a bit of inspiration from him to do these benchmark things to actually show you the impact that the code does, because I think that just hits harder, and basically you're thinking twice before you're leaving a bad code in your repository. Just leave for 5 more seconds. So how many of you have learned something new today? A lot. It's like 90%. Almost the entire room. Awesome. So key takeaways. I'll only leave, I have limited myself to only 3 so that you can remember them. INumerable is very, very dangerous. You might see something in the EF Core Microsoft documentation where it shows you something INumerable. Use it only if you understand why it's fast. Otherwise, don't use INumerable, please. And ASNO tracking can give you really good performance improvements for almost no impact. But make sure that you understand that anything that you'll do with that data will not be modified in the database. And the last one, I hope you've seen that we got from one code that fetches some data and then counts, and then another code that just includes a table and you don't know why it included that table, to a code that actually tells you what's going on. It became more performant, it was simpler to read, and it did exactly what you wanted. So sometimes you can have the cake and eat it. You just need to know how. And last part, if you want, I'll keep this slide at the end. You can come to me and scan it. You can win some good prizes. You can find the presentation over there. I can give you the link later. Thanks.